Okay, so what are the formulas for these compounds? Calcium hydroxide.
I don't know what the hydroxide is.
It sounds like what? Could it be something on here?
I was looking on that. I can't find it anywhere.
So what might it be?
I don't know.
It's a polyatomic ion.
Oh, polyatomic ion.
Yeah, so here we can see our hydroxide ion has a -1 charge, okay? And so we're combining the hydroxide ion, OH minus, with calcium. What's the charge on the calcium?
Calcium, I saw it on the periodic table. It's a +2 charge because it's a, uh, um, what do you call those?
A alkaline earth metal. These are alkaline earth metals.
The alkaline earth metal. So it's +2 charge.
Calcium has a +2, therefore I'm going to need two hydroxide ions, right, to balance it. So the chemical formula is going to be, whoops, try again, CaOH 2, like that. Very good. How about copper 2 chloride?
That 2,
Okay, give everybody a chance at home. Make sure everybody has tried all these at home before you proceed, okay? Okay, go ahead, Fred.
the 2 means the copper has a +2 charge.
Very good. The copper has a 2 plus charge. And because of that, we know that chloride ion, which is on the periodic table, and we know has to have a -1, we're going to be able to identify that the ratio has to be CuCl2. Okay, how about the ammonium phosphate?
Ammonium ion and the phosphate ion. They're both polyatomic ions, right?
They are both polyatomic ions, and we can look them up on our polyatomic ion sheet here and see that they are this NH4 plus and PO4 3 minus. Therefore, I'm going to need three, whoops, NH4, three of those for every phosphate. So that's our chemical formula for ammonium phosphate. Good. Here are some hydrates. Now, how do we name hydrates? Hydrates are named I mean, exactly the same, except for the end here. We use the prefix for the molecular prefix, mono, di, tri, hexa, whatever it is, and we say hydrate at the end. So what's the name of this part of the compound, Fred?
Um,
Hold on. Let's give everybody a chance at home. Everybody go home. Try to name all of these compounds here, adding in like dihydrate, hexahydrate, trihydrate, and let's see how you do. Okay?
are they ready?
I think they're ready.
Okay, so that's calcium sulfate.
Very good. Calcium sulfate dihydrate. Calcium sulfate dihydrate. Okay? How about this one?
That is cobalt 2 chloride.
Very good, Fred. Cobalt 2 chloride. Cobalt is a transition metal. It has multiple charge states, so we need some clarification. Because we know that there's two chloride ions, we know that each chloride ion has a -1, so every one cobalt combines with two chlorides, it must be the cobalt 2 ion there. So cobalt 2 hydrate, cobalt 2 chloride hexahydrate. How about this one?
Iron 3 iodide trihydrate.
Very good. Iron 3 iodide trihydrate. Excellent stuff.
Thank you.
All right. Which of these is the correct name for this compound?
Um, Everybody at home, you take a second to find out.
Thank you, Fred. Good job. All right, they did it. Now what?
The answer is copper sulfate, copper 1 sulfide.
Very good. Copper 1 sulfide. Let's go over this one. It's a little bit tricky for some people. Okay? Cu2S, we knew that. So we knew that there was two coppers for how many sulfide ions?
Just one.
The sulfide ion we can identify because of its location on the periodic table. It's always going to be a -2. Now that there's two coppers, each one of them has to have what kind of charge?
+1.
Each one has to have a +1, and that's why we call it copper 1, because the 1 is an indication that the charge on each copper is a +1. Okay? All right, very good. So, another one. Take your time at home. Solve this one. All right. They got it. What is it, Fred?
It's D.
That's right. I need 2 ammonium ions. They have a +1 charge for every sulfate ion, which has a -2 charge. All right, now we're going to spend a little bit of time naming acids. Acids. Now, acids, we haven't talked about where they fit in our diagram of all of our compounds. Okay? Compounds, all of our compounds, can be thought of as either ionic or molecular. Ionic compounds, how do we distinguish them right now?
Made of ions?
Made of ions, and almost always contain metal, or if they contain metal, they're ionic. Made of ions. Nonmetals, sorry, I gave it away. Molecular,
Nonmetals.
that's right, made of nonmetals. All right. When I put molecular compounds into water, do they result in ions?
What do you mean?
Remember how we said that if I take something like sodium chloride, which is an ionic compound, and I put it into water, it dissociates into its ions. Do you remember us talking about that?
Yeah, I remember that.
All right. And we said that that results in conductivity. Remember that?
Yeah,
In conductivity in a solution, right?
yeah.
Nonmetals, or molecular compounds, sorry, compounds made of nonmetals, like water, they don't conduct electricity, do they? Those ions are what contribute to the ability to conduct electricity. Well, it turns out that there is a class of non-metal containing compounds, or molecules, which, when placed into water, actually dissociate into their ions. And these are called acids. All right? So an example is HCl, hydrogen chloride. When you take hydrogen chloride and you put it into water, it actually will dissociate into ions, like that. Acids are compounds that, when placed into water, they're molecular compounds that, when placed into water, they dissociate into their ions. Okay? And acids always contain H plus ion, the hydrogen ion, as one of their ions. Okay, so we want to learn how to name these compounds. Some of you have a memory from somewhere, and again, maybe you don't know where, that HCl is hydrochloric acid. It's true, if you take hydrogen chloride, that's what the name of this molecule is, hydrogen chloride, and you put it into water, it dissociates and becomes known as hydrochloric acid. Right? Hydrogen chloride in aqueous, AQ, HClAQ, right, becomes hydrochloric acid. All right? So, hydrogen chloride, HCl gas, hydrochloric acid. The way that we name this compound, this acid, if it's binary, now binary means, again, just 2 elements coming together, it's hydrogen and chlorine coming together, is we follow this hydroblankic acid model. Hydrosulfuric acid, right? So if we had something like this, HBr, we recognize that it's binary. Therefore, we say, okay, it has to be named following the hydroblankic acid model. So what do you think? What would the name of this acid be, Fred?
Hydrobromic?
That's right, hydrobromic acid. So if they're binary, they follow that model, those rules. If the compound is an oxoacid, and oxoacids are acids that contain oxygen, really easy to distinguish, to recognize. They're also acids that contain polyatomic ions. Polyatomic ions, like this here, nitric acid, is the nitrate ion with enough hydrogens to balance its charge. We'll bring in our polyatomic ion chart and find the NO3 ion, which is the nitrate ion. There it is, nitrate, has a -1 charge. If I want to turn NO3 minus into a hydrogen, I just need one hydrogen. Each hydrogen has a plus charge. So HNO3 is the acid of the nitrate ion. And the 8 on nitrate helps me know that the acid's name is going to be ic for nitric acid. So if the polyatomic ion ends in 8, the acid ends in ic. SO4, that's the sulfate ion. Therefore, this is sulfuric acid. All right, sulfuric acid, nitric acid. 8, we say 8, nitrate, goes to ic. 8 goes to ic. If the polyatomic ion ends in ite, then the acid ends in us, yes. So chlorite goes to chlorus acid. Phosphite, that's the PO3, goes to phosphite, phosphorus acid. Okay, good. So the chant that we tell ourselves every night before we go to bed to remember the naming system for oxoacids is 8 goes to ic, ite goes to us. 8 goes to ic, ite goes to us. 8 meaning the name of the polyatomic ion ending, and ic meaning how we name it as an acid. Ite, polyatomic ion ending, going to us as we name it as an acid. All right. And recognize here that this is not hydro anything. There's no hydro involved. The hydro blanket model naming acids is only for our binary acids, HCl, for example, or HBr. Okay, good. So let's do a couple of examples here. Which one of these is correct? Which one is not correct? Which one is not named according to the hydroblanket model?
Only binary acids are hydroblankic, right?
That's right.
So I guess C is the answer.
That's right. This is nitric acid. It's not going to be called hydroblankic acid because it's an oxoacid. All right. How about that one? What's the name of that acid?
It's an oxoacid.
Very good. It's an oxoacid, so we have to name it using the name of the polyatomic ion.
Does that mean is the nitrate? Nitrite. Nitrite? Is that what that says?
That's right. Nitrite ion right here.
Ite goes to us. So nitrous acid?
Very good. Nitrous acid.
That's also an oxoacid. Let me look on that chair. Perchlorate ion?
Perchlorate.
8 goes to us.
8 goes to ic.
8 goes to ic. So perchloric acid?
Very good. Perchloric acid. 8 goes to ic, ite goes to us. 8 perchlorate is now perchloric acid. Good.
That's binary, so that's easy. That's hydrofluoric acid.
Very good. Hydrofluoric acid.
MnO4. Oh, that's a polyatomic ion, isn't it? Okay, so that's permanganate. 8 goes to ic. Permanganic acid?
Good. Permanganic acid.
Carbonate ion. Carbonic acid.
Very good. Carbonic acid. All right. Which of the following is the correct name for HClO3?
ClO3, that's on there, that's chlorate, 8 ic. Chloric acid?
Very good. Chloric acid. Last one. Take time at home to name it if you haven't done it yet.
H2SO3. Is that the sulfite ion?
That's right, sulfite ion. So H2SO3, sulfurous acid. Ite goes to us, so it's going to be sulfurous acid. Good job, Fred.
Thank you.